Okay, so here's our environment. We got our standard Kali box and then a couple systems on the network, right? So let's launch the Kali box. Again, here's, by the way, here's the lab manual. You can download it by clicking on this button right here. Open it up on your machine. Okay, so let's go to our Kali box. Let me tighten this up a little bit. I'll move it around as needed. So we're going to click on Other. Username is root. Password is Tor, which is root backwards. Okay, we're in. Let's get that terminal going by clicking the icon at the top there. It looks like a little black square. All right, so we got a terminal shell. Let's go to a change directory, cd to temp random. Okay. We're going to create a new document, nano, which is just the text editor in Linux here. We're going to call it secret.txt. Very, very overt on what we're doing with this file. Okay. Now, type a message below. So let's see. What's our secret message? They have something in here, but attack at dawn. Right. Whatever the secret message is. This is a military type command. Or don't trust Bob, right? Whatever it is, okay? So I'm going to hit Control X. That's going to say at the bottom. Do you want to save this buffer? I'm trying to show you guys, right? You should get this. Save the buffer. Just hit Enter. Right, you can't hit Enter. Hit Y, and you get for yes, and then file name to write, secret.txt, which is fine, and press Enter. So Control X, Y, Enter is how you get out of there. So now you can see, our text that we just wrote is in this secret document. All right. Now how do we communicate this secret document to our confidants without it getting in the wrong hands, right? Because this information is not useful if Bob finds out that we know that we're on to him, or that our enemy realizes we're going to attack at dawn. So what we're going to do is we're going to use steg hide. Steganography is the technique of hiding data in images, okay? And I'll explain to you in a second how that can work. But steg hide info earth.jpg, okay? All right, you can see it's a 5.5 kilobyte, excuse me, file. It's a JPEG, which is pretty standard image file. All right, we're gonna put no for try to get information about embedded data. Okay, now I'm kind of curious here. This isn't part of the lab, but I do want to do this really quickly. Where are we in temp random? Yeah. Where's this earth? Here's our secret file that we made, and then here's earth. Okay, so check this out. Not part of the lab, but I just want to show you what this graphic or this image looks like, right? This is the file. You can see. Okay, we'll come back to this. We'll come back to it. Okay, so here's our shell. So now we're going to hide it in the earth image. So let's do du-b, which is disk use. It's just to kind of see how big it is, right? It says it's 34 bytes. Now, the lab manual says 44 because I didn't type in exactly what the lab manual said to type in. So if you typed in something different than the lab manual like I did, your value will be different, but that's fine. The point is going to still work for you, okay? So now let's do SHA-1 sum on the earth image. So SHA-1 is basically a hashing, it's a hashing algorithm. So you can't, hashing algorithms, I probably will explain this in lecture, but hashing algorithms are one-way mathematical functions that basically allow you to give kind of unique identifiers for files. So this earth.jpg file this is its SHA-1 hash. It's very, very uncommon to have, two files with the same hash, right? So what we're saying is this hash is equal to is kind of the fingerprint for this file in its current state, right? Sometimes you'll see hashing algorithms, or excuse me, hash values on sites that have software you can download. So when you download it, you can run the hash on your machine and verify that the version that you just downloaded is consistent with the version that the developer published on purpose. Because if someone swaps it out for a malicious one, that hashing value is going to be different. Okay, that was a little bit of a tangent, but now let's use steghide embed -cf earth. So embed into what image, and we're going to do ef secret.txt, right? So we're going to use steghide to embed in the JPEG earth.jpg file the secret.txt document, right? So we need to enter secret. Well, you have to put in a passphrase, right? I'm writing secret. Okay, cool. So now let's do this again, and I just want to point out, do you see how, because we changed the file, that hash is different now? So if you were hashing your files, you would know immediately that something has happened to this earth.jpg file. Now check this out. I do want to show you something really quickly. Right? This is earth.jpg. Right? Now here it is with the text hidden in it, right? It looks exactly the same, and it's going to, right? So this image I could send to someone and they'd be able to extract the hidden information, but if you just saw this image, you wouldn't think twice about it being, more than it appears, right? And that's the power of steganography. So now let us, we verify that the file's integrity has been compromised, but most people don't do hashing on files. They just look at the graphic, right? So let's do that steghide info earth like we did before, okay? Now, this looks very similar to what it did before. Okay, hold on one second. Let me get this tight. Okay. So you can see when we ran it earlier, JPEG, JPEG 55, JPEG, JPEG 55. So even though it's got the hidden stuff in it, it still appears the same, right? But now let's see if we can get information about the hidden embedded data. Enter the passphrase. So if you don't have that, you know that there's something hidden in there, but you can't actually access it through, this mechanism. I typed in the password secret that we did when we embedded the text, and now we can see that in fact there is a secret.txt file embedded in the image, size 34 bytes, which is consistent to what it was up here, right? And it's encrypted using Raindoll 128. Okay, so now we've put it on Instagram. We use hashtag, yum yum or whatever, to indicate, hey, there's a secret message here. I should download this image and use steghide. So let's do steghide extract -sf, and what file are we extracting it from? I'm going to type in secret. The file secret does already exist. Overwrite it. Well, that makes sense because it's in the same directory. Okay, so we wrote that, and now let's look at our secret message. Ooh, don't trust Bob. Good to know. Okay, so that's it. Go ahead, run the lab the same way. I'd be curious actually to see what you put in your secret text file, But take a screenshot of of your terminal shell like this. Basically, let me see that stag hide extract SF earth, and then kind of what your secret text file looks like. Just do a snapshot of that, upload it to the lab, and that'll be the assignment for this particular lab. I hope you had fun secretly hiding information in images. It's kind of funny as far as steganography goes. Very difficult to detect. Actually, it's easy to detect if you know to look, but most people don't look, right? And every couple years, steganography like has a big splash in the industry, and then it'll go away for a while, and then it'll have a big splash a couple years later. So hope you enjoyed the lab. Thanks so much.